Can we start, Danish? I think it's 6:05.
Okay, ma'am.
Okay, so let's me introduce myself once again. I'm Jyoti Sharma, and this is week 12. This is the end of this semester, and I'm doing TA-ship for the course Conservation Geography. So let's start with this week 12 from 6 to 8. Don't worry, Danish. I think I may have 2 hour more class for the next week to get more credit. Anyway, we have the topic of this is the special topics in geography and conservation. So, and these special topics are, the first is remote sensing and GIS, the second is disaster, and third is evaluation of natural resources. So let's start with the remote sensing and GIS, then we will go to the disaster and so on. My slide is visible to you, Danish, right?
Yes, ma'am.
Okay. Yes. Okay, so remote sensing and GIS. Before going to remote sensing and GIS, we have to consider what do you mean by photogrammetry. So because remote sensing is a one type of photogrammetry only. Um, so here we can see photo means light, gram means drawing, and meter means measurement. So if we are getting some data from photos, okay, without touching the body or the object, then this will be known as the photogrammetry. Okay, so here the definition is: photogrammetry is a art, science, and the technology of obtaining reliable information about physical objects and the environment. Not only we are getting information about that object, but we can also get information about the environment as well. For example, if there is a fog in Delhi, so after capturing a picture from there on the road, you can get the information that yes, this is the foggy condition. It may be that you can see the brown fumes. Okay, so based on that you can say that yes, there is a higher concentration of nitrogen oxide as well, or there is sulfur dioxide. So based on photography, you get the information about the object. The first thing is, like, from photography you can photogrammetry, you can say that yes, there is a like huge traffic in Delhi, so you are getting information about the object. Second, if you see the fog, then you can say that yes, there is like, we also have the information about the environment as well. Okay, so we are getting information about the environment, and there are some processes within this photogrammetry. So these are the recording, measuring, and interpreting photograph images and the pattern of recorded radiant electromagnetic energy and another phenomena. So basically what happened in that, the basic rule of photogrammetry is that you are giving some light, and this light will reflect it to you back. Okay, and the reflected light may have some information about the object and about the environment. So what whenever you are talking about the remote sensing or the photogrammetry, it is basically about the electromagnetic radiation you are sending to the object and whatever you are getting. So whenever you are getting it, electromagnetic radiation have some kind of specific wavelength, and and it also consists of many information about the object or the environment. So we have to study how different type of peaks we are getting of this electromagnetic reflected radiation. So this is all about the photogrammetry. Then if we okay, Kuldeep, our topic is see, we have three topics here in this special topic in geography and conservation. So firstly, we will talk about remote sensing and GIS. Then we will talk about disaster, and lastly, the valuation of natural resources. And right now we are talking about remote sensing and GIS. So basically, this is the first slide I talked about, and this is all about the photogrammetry, because remote sensing is very much part of this photogrammetry. Is it clear, Kuldeep?
Yes, ma'am.
Okay. Okay, so what is remote sensing? Do you have a course of remote sensing in your undergraduation or not?
Ma'am,
Yes, ma'am,
yet
we have.
not.
And you have completed it, right?
No,
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 ma'am.
ma'am. It
Okay,
will
so
be in our upcoming semester.
Ma'am, in next semester we have geospatial techniques.
okay. Okay, so let's have some introduction about remote sensing first, then you will go to the advanced version in your class. So remote sensing is nothing. Remote means something is away from you, and sensing means you are sensing it. Like if you are not touching it, but you are getting information about any object or the environment that is away from you. So this is the remote sensing. The definition is it is the process of detecting and monitoring the physical characteristics of an area by measuring its reflected and emitted radiation at a distance. This is same like the photogrammetry, because of remote sensing is a part of this photogrammetry. So what you are doing, like you are sending some radiation, this radiation will emit or the reflect, and this will give you some information. Okay, so and because you are not touching anything, you are not touching any object, so this is that's why it's a remote sensing. You are sensing something from the remotely. Okay, then we use spatial cameras for this kind of remote sensing, remote sensed image. We will talk about some kind of cameras. And okay, so these cameras can be the first thing is you are getting information without touching the object. So how you can get the information? By the photogrammetry. Okay, and this photogrammetry can be done using different type of cameras, and the location of camera may differ based on the area you want to study upon. Okay, so for example, you want to study only one tree. Okay, so for one tree you can use the basically whatever the DSLR camera you have, so you can install that camera. And for example, per day it is taking the picture, and whatever the phenology you have, phenology means whenever the flowering is coming, whenever the leaf comes out, so this kind of information you can get only from the DSLR. Okay, but if you want to get the information of your let's say the farming land, okay, this farming land may be 1 hectare, 2 hectare, or 3 hectare, so you must need the aircraft, and in that aircraft you must have sensor or the cameras uh, 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 by which you can take the picture of that area and you can get some information. Okay, so the first will be the ground based, as I talked about the DSLR. The second will be like using the aircraft, and third will be the satellite. If you want information let's say about the earth, okay, so for such kind of situation we need satellite. In that satellite we have some sensors, and these sensors will sense this type of radiation. They will get the reflected radiation from the surface, and you will get also some information from these satellites. Okay, so we talked about satellite, we talked about aeroplane or the aircraft for that. Then we have the sonar system as well. Do you know the full form of sonar? Have you listened about sonar system earlier?
Yes, ma'am.
Okay, so
No,
what's the full form of it?
Ma'am,
This is sound, next sound navigation and ranging.
okay.
So what happens when there is a ship on the ocean? So because there is some kind of structure or the hills or mountains on the ocean surface. Okay, and whenever the ocean is navigating, you must have the information if there is some hill upright just before the ship or not. Okay, you need some information about the surface of the ocean before navigating your ship. So this is like sound navigation and ranging means we have some kind of device on the ship. That device may give the sound signal, okay, below the ocean, and below the ocean it will strike upon the surface and it will reflect back. So based on the time it has taken, based on whatever the wavelength, whatever the speed of that sound wave we sent to that surface below the ocean, we can get the information how much distance we have between the ship and, let's say, the hail. Okay, so that the ship can navigate very easily. So this is the kind of working the sonar system have. So sonar system on ocean, on ships can be used to create image of the ocean floor without needing to travel to the bottom of the ocean. And whenever there were the exploration of the ocean, so these kind of sonar system usually uses. Okay, then the cameras on satellite can be used to make images of temperature changes in the ocean. Uh, okay, there is a very simple definition of remote sensing once again. So this is the acquisition of information about an object or the phenomena without making a physical contact with the object. Okay, and whatever the reflected light, it will give the information to the sensor, and then sensor will give information to the antenna, or we will do some kind of processing. So what kind of information? It can give the information about the size and the color of object. The second is different properties, and it may also tell, it also tells us that whatever the temperature of that object is. So there are a lot of like applications of the remote sensing. We will discuss in next slide as well. So this is the crux. For example, this is the sun. Sun give the radiation to, let's say, the grasses, to the building, to roads, to the forest. Okay, so this is the incident solar radiation. This light will be reflected back, but this reflected light will be captured by the sensor. Okay, and because this reflected solar radiation will have some information about the objects, about this building, about this grass, about this forest. And after getting this reflected light by the sensor, it will give this data to the server, and this server will acquire such kind of information. So this is kind of the working of remote sensing, or using satellite. So we have two different type of remote sensing. The one is passive and one is active. It is dependent on the source of radiation we are getting. For example, the source of radiation is sun only. It can be possible in the daytime only, because in daytime the sun will give you the incident solar radiation, and the reflected back radiation will be taken by the sensor. Okay, so this is the passive remote sensing. But for example, you want data in the night time. Okay, and it may be possible that you want data, you want this reflected light in different wavelength. And what will you do? The sensor will give the light first to the object, and the reflected light will be taken upon also by the sensor. So here there is a no need of sun. That's why we have to give the energy to the surface first. So this is the active remote sensing. So can you tell me, like, which type of radiation basically the sun gives on the surface, or the earth? Like
UV radiations.
Ma'am,
okay,
short
what else?
wavelength radiation.
Yes, short wave and long wave is a different criteria. I'm talking about, like, what's the range of wavelength, basically the wavelength of that radiation that usually sun gives, in nanometer or micrometer, or you can like give me the name of it.
I
Does
don't know.
sun give you the radio wave, or gamma rays, or infrared rays?
Yes, ma'am.
No.
Uh,
Most yes,
Ma'am,
Ultraviolet rays, no?
some kind of like
ultraviolet rays,
some range of.
IR.
Yes, Kuldeep, you are saying something, right?
Yes, ma'am. IR rays and Vivior.
Yes. So what happens that because sun have a very high temperature. Okay, and what's the value of that temperature the sun have? Approximately 5700 Kelvin or 5800 Kelvin. Like it's above 5000 Kelvin temperature we have. And the wavelength is basically inversely proportional to the temperature the object have. So if there is a high temperature, okay, then the wavelength will be very low. Very low wavelength means it will be powerful radiation. So basically, because of the ozone, because of the higher temperature of sun, we are just getting some ultraviolet radiation and some visible part that you are talking about, the VIBGYOR. Okay, so sun is mostly giving us the visible as well as the ultraviolet radiation, most of the part, and some part of near infrared radiation. So this range the sun gives us the radiation. Okay, but what happened, because the temperature of our earth is not that much high, so it means the wavelength that earth will reflect will be the long wave radiation, and it will be infrared radiation basically. Okay, and sometime we need another kind of radiation to get some another kind of information. For example, satellite need the radio waves to be incident on the surface, and we want it be reflected on the sensor as well. Okay, so from where this radio wave will come? So we have to give the radio wave to the surface or to the earth. So this kind of things can be happened only in the active remote sensing, but not in the passive remote sensing, because in the passive remote sensing only sun is giving you the radiation, and sun gives mostly in some part of ultraviolet, some part of visible, and some part of near infrared radiation. So we may get very half knowledge about the things. Okay, so have you understood what is passive remote sensing and what is active remote sensing?
Yes, ma'am.
Danish, is it clear?
Yes, ma'am.
Okay, so this is all about the remote sensing. Okay, once again, we come to the photogrammetry. So the principle of photogrammetry is the triangulation. So what do you mean by triangulation? Have you read about the trigonometry earlier? In maths, we have the trigonometry chapter. So do you know what do you mean by triangulation or the trigonometry? Kalip,
Yes, ma'am. I
Danish?
have studied, but I don't have any idea about triangulation.
Okay, so like triangulation is you are creating the triangle to get some information. Okay, we have two eyes, right? And we know the distance between two eyes. And if we are seeing some object, okay, so our one eye will have one angle with respect to that object, and our second eye will also have some type of angle with respect to that object. So we have like the distance between eye is very much determined and confined. So we know the distance, like we know the base distance. Then we also know, like we also have some device that can give us the angle we have with our eyes and the object. Okay, so based on this angle, based on the distance between our eyes, we can estimate the distance of our eye to the object. So this is kind of triangulation. So based on this triangulation, we can estimate or we can measure the distance of any object from our eyes. So this is triangulation. I also have, yes. Here, for example, there is a point A, there is also point B, and we want to measure the distance, whatever we have of this tree from this A and B baseline. Okay, but we know that there is some kind like triangulation is basically used when we can't measure directly the distance, because there is a river, so it is not possible for us to use the meter tape or something else to measure the distance of this tree from us. Then like there is a let's say this is one eye, this is second eye, and there is some distance between these two, and we are creating some angle with the tree. We are creating some angle with the tree from this B object as well. So based on the trigonometry, sine theta or tan theta, we can estimate the distance between us and the tree. So this is kind of triangulation, and this triangulation is the principle for also locating the object using the satellite as well. Whenever you have more than 3 or 4 satellite, and based on that you have the triangulation, this triangulation will help you find out the location where the object is. So this is the triangulation. Then here is the method, like how can you apply this triangulation. The first is, we have to take the photograph from at least 2 different locations. Let's say you are taking photograph from A and B. Then you have to develop the line of sight from each camera to the point of object. So these are line of sight. This A from tree, A to C, and this B to C. These are the line of sight. So you are creating the line of sight, and the you also have the angle with which angle you are seeing this tree. So, and then mathematically you are calculating the 3D coordinate of that point of interest. So this is the triangulation principle we have under this photogrammetry. The application are different. Like the application can be interpretive and as well as the metric. For example, we have one satellite product, and that satellite product is for the 10 years. Okay, and this 10-year product, you can see that 10 years ago there was a forest, but right now it has been converted into the agricultural land, or let's say the different kind of land. Okay, so this is kind of interpretive. But you can also measure how much of the part of that land has been converted into the agricultural, or let's say grassland. So you have the quantitative value as well. So in that case, this is metric application. So you can measure, you can tell like how much hectare or how much kilometer the area has been converted from the forest to, let's say, the grassland. So this is kind of the metric. I think triangulation thing is clear to you. Kuldeep, Danish?
Yes, ma'am.
Yeah. Have you ever used this Google Earth as well? Google Earth Pro. This is very informative, actually.
Yes, ma'am. Today, I mean, I use it all the time and most of the time.
Oh, okay, okay. So this was
Ma'am,
the
is there anything? Is there anything like Google Earth Pro?
Yes, we have the Google Earth Pro as well. Like we are using it for the satellite purpose. Like from there we can get some information, and we can like analyze in the ArcGIS software. So we usually do such kind of works.
Where can I access the Google Earth Pro?
You can download it. Like it's a kind of software we have. You can download it in your desktop, and then you will get it.
Okay, okay, ma'am.
Okay. Okay, so we basically have talked about it earlier. Kind of like I told you that it can be the ground-based camera. It can be the camera that is upon the drones or on the aircraft, or the camera can be on this satellite. Okay, so this is all about the platform we are using to get the images. So the first is ground borne, means you are using camera on ground. Here the camera position is very horizontal to the object you have. Okay, then we have the airborne, means we are using aircraft for that, drones, helicopter, whatever we are using. And here the camera angle can be changed. Okay, so here it can, like camera can be at any angle. Then we have the spaceborne. We are using satellite data, and here the camera is very much vertical. Means the object is just below it, and the camera is like that. Okay, so this the camera is vertical inside, vertical in position, means top down view. So you have to keep in mind that there are different like advantage and disadvantage how our camera is at that position, either it is horizontal or it is vertical, or it has a different angle. So based on that angle of the camera, we can get some information, or the information may get distorted as well. So we have to keep in mind like what angle you are keeping to capture the information. Okay, so we have a image. Okay, so for that image we have four different type of resolution. The first is spatial resolution, the second is temporal resolution, the third is spectral, and fourth is radiometric. I think you people very much know about the spatial resolution. So for example, we have a state, or let's say city, Delhi, and this Delhi, in how much pixels we are dividing Delhi. Okay, for example, we are capturing Delhi within only 1 pixel. So you will get a very blurred information about Delhi. But if you have, let's say, 100 or 1,000 pixels within Delhi, so each pixel we have some value, and this image will be very finer in resolution. So this is kind of spatial resolution. So let me show you once this. Okay, here we can see it was a polygon, and this is 5 meter resolution, this is 10 meter resolution, and this is 30 meter resolution. The size of pixel will decide the your image will be finer or blurred. Okay, if we have very small size pixel, then it will be the higher resolution. But opposite to that, if you have a large size pixel, then it will give you the very lower resolution image. Here we can see that this is a high spatial resolution, and here we can see some pixel, because the size of pixel is large, so we can here see the square size, square pixels, and this is giving you the blurred image. So this is the kind of spatial resolution. Then the second, we have the temporal resolution. For example, satellite is giving you image daily or monthly or weekly. Okay, so this is the frequency. Yes, exactly. The movie quality, it is 720p, or yes, it is just same like the spatial resolution. Then I was talking about temporal resolution. So this is like how when the satellite is coming back to the same place and giving you the same picture. Okay, so it is kind of the frequency. You can get the image daily, you may get the image weekly, you may get the image in 16 days, you may get the image like in 1 year. Okay, so this is kind of temporal resolution. I show you one picture I have, I think. Yes. So if you see, like, it is the date 1, this is the date 2, and the difference between this date 1 and date 2 may vary, like it may be weekly, it may be daily, it may be yearly. So this is all about the temporal resolution. Whenever we have a very fine temporal resolution, means we are running some models, and these models are giving us data of 3 hourly. Means after 3 hour, this model is giving us the data. So based on this 3 hourly data, we can predict like how when this cyclone will on the surface, or like where the wind is, when this wind will come upon this northern plain. So like microclimate can be described because of very good temporal resolution. If we have, let's say, the monthly temporal resolution, then we can't predict our weather condition. Exactly, because for the weather we need hourly data or 3 hourly data. So a different type of temporal resolution will have different type of applications. For example, if I want to work on vegetation, so how vegetation are being affected by the climate change. Okay, so daily we can't see very much difference between among this vegetation. It takes like hundreds of years or at least 10 years to get some change in that particular area, to have changes in the vegetation. So for that we don't need very finer or very finer temporal resolution. If the temporal resolution is monthly or yearly, then it is okay. Okay, so this is the temporal resolution. Then the third is spectral. This is very important actually. For example, the land is behaving different with different type of radiation. Water is behaving with different type of wavelength. Okay, for example, if you see that uh, we have water, and this water have a different kind of absorption peak for different wavelength. Okay, and it may be possible that suppose we have land, we have the water. Okay, and in the invisible light, both have the same absorption or the reflectance curve. Okay, means these are behaving very similar in the visible spectrum. Okay, but it may be happen that in infrared radiation or in the radio wave radiation, this land and surface, the reflection curve is different. For example, water is just absorbing the infrared radiation, but the surface is not absorbing the infrared radiation. Okay, so means the reflectance curve is different for the land as well as for the water in infrared radiation, but the reflectance curve is same in the visible radiation. So it means that our sensor should be like that. uh, each sensor must sense different type of wavelength. Okay, and if it is not differentiating between different kind of wavelength, then we will call it a low spectral resolution. Are you getting it? I show you one picture. Okay, here we have let's say blue. This is the visible light. Okay, when our sensor is sensing just the visible light as a one band, and it will give you some image. So this is the low spectral resolution. But if your sensor is sensing these with your light as a three different bands, then these three bands, like it is like three different type of radiation you are getting, and three different type of radiation you are the surface is reflecting, and these three different type of radiation can be captured or sensed by the sensors. So this is the high spectral resolution. As I told you, different surface may have may behave differently in different wavelength. Okay, so here we have the high spectral resolution. This is the example. Here you can see this is the reflectance curve, like which at what wavelength we have the highest peak of reflected light for different objects. For example, we have the sea water here. Can you see that sea water have the reflectance high in the wavelength of 0.2, but it is going down after it. Here we can see for the limestone we have different reflectance curve. For this dry grass we have different reflectance curve. Okay, and let's say for this red and yellow, miss asphalt road and brick, in like from 1 to 4 1.4 to 1.8, the reflectance is same. So you can't differentiate what this object will be. You can differentiate it from here 0.8 to let's say 1, because the reflectance curve is different for different type of object. So our sensor should be like this. It can sense different kind of wavelength as a different kind of bands, so we can get the information very efficiently. Okay, so this is the spectral resolution. And then the radiometric resolution. Radiometric means if you have one bit, in one bit you know that it start from white to black. Okay, so from white to black, like how it is able to capture the difference, like from white to light gray to gray, gray to black. So how these values can be differentiated within one pixel. So this is radiometric. I show you. Huh. If it is a 1 bit, then you will have either white or black. Okay, but if you have 8 bit, then in within a pixel you can have 255 shades of white to black. Okay, but if your image have 16 bit, then within one pixel you may have the shades from white to black, and you can divide the shades like from 0 to 65535 and so on. Okay, so means your sensor or your image should be like this, which have a very nice bit. Okay, so this is kind of the radiometric resolution. I think 4 type of resolution has been cleared. The first is spectral, based on the pixels, the size of the pixel, then the temporal, the frequency of satellite getting the data, then the spectral, whether this satellite is able to capture different type of wavelength bands, and the fourth is radiometric. Yes, Kuldeep, you want to say something?
Uh, yeah, ma'am. Ma'am, what is EMR?
EMR is electromagnetic radiation.
Okay, okay, ma'am.
Yes. Yes, Danish.
Ma'am, what was LIDAR? LIDAR in the previous slide.
I couldn't see. Where is?
Here,
Okay.
LIDAR at
Okay. I
1
will talk
point.
about it as well. Um, this is light detection and ranging. We will talk about it in next slide as well.
Okay, ma'am.
Yes. Okay, so whenever if you want to download some satellite data, so you have some kind of websites. Okay, and the one is Earth Explorer or USGS, in which you have different satellite, and different satellite may have different type of resolution. So here we there is a one data set. This is known as the Landsat. Okay, so Landsat means it have there is a different version of Landsat. Once upon a time, it was 4 and 5 Landsat data. Then something has been added into that data, and this data set is known as the Landsat 7. And there is also one data set that is from 1 to 5, based on the version, based on like how much improvement we have gone through. Okay, so we have different type of we have same sensor, but with some improvement we have a different version of that data set. Okay, and this has improved our resolution as well. So if we compare the spectral resolution, means in this Landsat 4 and 5 we have 7 bands, means 7 different interval of wavelength it can sense differently. Okay, so we have the 7 bands. If we are talking about Landsat 7, we have the 8 bands, means 8 different wavelength interval it can sense. Okay, then we have 1 to 5 because it was a very primitive. So here only green, red, near infrared or infrared, 4 band, 4 wavelength interval it could sense. Okay, so this is the spectral resolution. The higher the number of bands we have within an image, the image quality will be better for the information we can we want to get. Okay, the spatial resolution, this is the size of that pixel box, the length and the breadth of this. So here we can see it is a 30 into 30, and we also like in one satellite image we can have different type of spatial resolution as well. For example, it is also giving 30 into 30 meter data, and also 120 into 120 meter data. If we are talking about the Landsat data, then it is giving 15 into 15 meter data, means this is giving you the size of the pixel. Okay, and it is also giving 30 into 30 and 16 to 60 data. And this Landsat 1 and 5, these are giving this much spatial resolution. if we have the spatial coverage as well. In one go, how much area the sensor is in in one go, like once how should I uh, okay, so if we have a like sensor, then sensor will give some light. Okay, and in a one go, it will this light will be reflected and give you the information. So how much area has been covered by this electromagnetic radiation, because for that area it will give you the information. So at a one time, how much kilometer coverage you have by this sensor. So this is the spatial coverage. Then we have the temporal resolution. For example, like Landsat 4 and 5 give you the data uh, of 16 days. Like after 16 days, it will give you one image. After 16 days, it will give you the another image. So 16 days, and the 18 days. Then we have the altitude. So what's the altitude we have of our sensor or the satellite? So this is 705, 705, and so on. So this is kind of information we need before downloading our satellite data. We must know that, okay, if we want to work on vegetation, we need how much spatial resolution, how much temporal resolution we need. And because if we are talking about the vegetation, then most of the information we can get only from the green, red, or infrared radiation. We don't need different this MIR or the panchromatic data. Okay, so here we can only download this Landsat 1 to 5 data set only. We don't need to download this 4 and 5 or the 7 Landsat data. So based on our requirement, we can download our data, but before that you must know the kind of resolution we need for our work. Okay. Okay, so I told you that remote sensing is all about the photographs. So you must know how you can capture a good photograph. Okay, so there are some rules to get the like good photographs, and these good photograph are based on like the field of view you have, the focus you have, and the exposure you have. If you have used DSLR earlier, then most of the terminology you may have learned already, but if you are not, it's all right. Okay, so we have the field of view. Have you ever used the binoculars for the bird watching or something? Have you
No,
any?
ma'am.
Okay, so if you see like if you have a binocular like this, you can like change the angle, this one. Okay, means and after changing this angle, you are just telling your binocular how much area you want to focus upon. Okay, so this is the angle angle that will give you the extent of the area you want. So like binocular, you can move like this, you can move like this, and if you use even the microscope as well, you can change the field of view. This is nothing but the angle, and based on this angle you can decide how much area you want. If your angle is low, means you are focusing on a very in a very low area. Okay, and if your focus is like if you want to work on 1 kilometer or 2 kilometers, so your angle should be more. So this is the field of view, and it's also depend on the focal length and the angle. Focal length is like of the lens, and angle I'm talking about. So the definition is it is the extent of observational bird or scene that can be seen at a given moment through a particular optical instrument, for example, camera, telescope, or the binocular. So we may have the wide angle lens, or we may have the like narrow angle lens, and based on that you can have a different portion of the area you want to focus upon. Okay, so I should have one image for this. Okay, so here we have this. This is the field of view. Based on angle, if this angle will be lower, then this field of view will be lower. Means the distance you can see by this type of instruments. Then we have the focus, and this focus depend on f number, and f number can be defined as the ratio among the focal length and the aperture diameter. So I show you the aperture diameter. Okay, so if you have a DSLR, you have the option to change the aperture size. Okay, and if you have a wide aperture means you can see the object in front of you, but at the back of that object, it will be blurred out. Okay, in the wider aperture. But if you have a narrow aperture, then you can see the people just ahead of you, and whatever behind the people or the object you can see also. So this is kind of the aperture you have to set to get the extent you want and the focus you want. Okay, so this is based on the aperture. Okay, so if we want the photography for far range, your focus should be at the infinity. And if you want a very closer photography, means like this. If you want image of this person only, not of the hut, then your aperture should be wider. Then we have the exposure. How much light we are allowing us to enter into the camera. Okay, and this depend on the shutter speed. So there is a kind of shutter, it just closes the, or it just inhibit whatever the light is entering. So it is just like this. So how much radiation, how much light we are allowing to enter into the camera, this will be the shutter speed. Then we have the ISO. ISO is like International Standardization Organization, and F number. So I also tell you about this ISO as well. Here we can see, like if we have a very like if we have a very low sunlight in our environment, but we want to get a very good picture. Okay, so we can increase our ISO. But you have to keep in mind that if you are increasing your ISO, then it will create some kind of noise as well. It means give you the grained image. The image will have a very grained like structure into that image. So for that, you must realize that uh, if there is a possibility, then the adjustment of the shutter speed or the exposure you can adjust, then it's okay. Because with the increasing in the ISO, there is some kind of noise you can encounter as well. So this is like raising your ISO also has some consequences. It will allow like it will give you the lot of grain in that image. If you are increasing the ISO, means noise, and this might not be the usable. So if you are brightening your photo by ISO, there is also a trade-off. Means and you should raise your ISO only when you are unable to bright your photo via shutter speed or the aperture. Otherwise, if you are not able to do it, then you can do it with the ISO. Yes. So the list ISO meant better detail. No. uh, ISO will give like whenever you are increasing the ISO, you will get a good image. But with the ISO, you will also get some noise as well. No doubt, it will give you the same kind of detail, but it will give you some noise as well. So this noise may not be favorable for you. So it has been told that instead of using the ISO, you can use the shutter speed or the aperture, and you can adjust the shutter speed and aperture, not increasing the ISO. So okay, so if you people have DSLR, let's say in next year, then you can use you can play with this word to increase or decrease the aperture, ISO, or let's say shutter speed. So you will get a better image in next year. Okay, so we have different type of orientation of camera axis, as I already told you. Like it may be truly vertical, it may be near vertically, and some angle can be here. Okay, and if there is some angle, then it will be like high oblique or the low oblique. And based on that, I already told you that based on this orientation, our image quality, the distortion, whatever have the coverage of the surface, coverage of the object, it will depend on the orientation of camera axis as well. Okay, here we can see this is our camera lens. Whenever the camera lens is just vertical to the object, or the, let's say, the perpendicular to the object, then we will call it as the vertical. Then if our lens have some angle with the object, then this is the low oblique, and this angle is higher, then this is the high oblique. And can you see that because of this angle we are creating in low oblique and high oblique, the surface area we had earlier has been changed. So based on the application, based on like how much area we need in a one go, we can change the angle of our satellite sensor. So, and here we can also see the distortion also we can get. For example, here in the vertical, we are getting the pixel very square in shape, but in oblique we have a little bit distorted pixel, and in high oblique we have more distorted pixels. So we have to do some kind of corrections in the picture before before applying it for any application, because this image may be distorted because of the angle we had selected. Okay. Then yes, we have different pros and cons of the vertical and oblique axis. These are vertical axis will give you more uniform scale, or the measurement will be easier, but here the scale will vary, and more across the photograph. This will be less distorted, this will be highly distorted. Then less masking by a fall object like trees or building, here it will give you the more masking. Then it cover less area, it will cover more area. It is very difficult into in the cloud condition. For example, if we see that there is a cloud, then we can change our angle to get that much area to be sensed. But if it is a vertical, then we can't change our angle. So in the cloudy condition, this oblique axis is more useful. Then it is difficult to measure in the elevation, but it is easier to measure in the elevation. So we have different pros and cons in the vertical and the oblique axis. Okay, as I told you that because of this angle, because of the height, because of the altitude, the image may be distorted. Okay, and if we are taking image from the satellite, or let's say from drones or from aircraft, so then this image have to be corrected before before using it. Okay, so here as I already told you, with the elevation and the camera tilt, scale has been changed. The important thing is there, the parallax shift with the altitude. If you see, if you will for example, if you are in a train and train is moving, okay, and near the train you have the pole. Okay, you will see that this pole is moving very rapidly, but whatever is far behind the pole, you will see that this is moving slowly. Means if you are in a moving thing, or if you are a moving object, then whatever is nearer to you, you will see it moving very rapidly as comparison to the things that is far behind. Okay, so this is kind of the parallax effect. So parallax is the apparent shift in the position of the nearby object against a background or more distant object. Here you can see, like you will see that the behind mountains or trees are not moving, like they are moving very slow, but this man is moving very far at a very fast pace. So this is kind of the parallel effects. And because satellite or the aircraft is also is always moving, okay, so you will encounter with the parallax shift, so you have to correct it as well. there is more about this parallel effect. The one is, if you are a moving observer, you will see some object is also shifting. Means if there is a pole outside the train, you will see that pole is moving. Okay, you will observe it because it is the apparent shift. Then uh, near object shift more as comparison to the object that are far away. So this will change your depth perception. So you have to correct it before using. Okay. Then we have a measurement, how we can do the measurement. Uh, because we have a, let's say we have a image that is 2D, but you want a image that you want an image that is 3D. Okay, so how can you get the 3D image? For 3D image, you must have the stereo viewing. Stereo viewing means you are taking the picture of the same object from different angle so that you can get different angle of that object and you will get the 3D image. So this is the stereo viewing. And here also we have to take care of this parallax shift. Yes, we can see it that our left eye is seeing it from different angle, right angle is seeing this object from different angle, and based on that we can get the 3D image of this picture. So this is the stereo viewing. Okay, we have two or more different type of cameras. The one is metric cameras, means you can exactly measure how much distance you have from that object. And how it is possible, because there is whatever the internal geometric we have inside the camera, these has been fixed. Only then we can do the measurement with the images. If the internal geometrics means focal length or the shutter speed or let's say ISO, if these are not fixed, then it would be very difficult to measure the distance with the image only. Okay, so if you want to measure something just using the image, then that camera should be metric. Okay, means internal geometry should be fixed. So here there will be very low lens distortion, the stable and precisely no internal geometric, and constant focal length. There are also some marks through which you can identify the coordinates you have, and most of the aerial metric camera built into airplane look straight onwards. So this is the metric cameras. Are you people flipping or listening to me?
Yes, ma'am. Listening to you.
We are listening.
Okay, have you been bored because today I'm not asking you the question? Because
Yes, ma'am.
I
I was thinking the same.
because I thought that it may be different for you. So if I'm asking you the question, you may not able to answer it very frequently. So I thought that I should learn you first and then ask the question later. Is it right, or I ask you question in between that?
Ma'am, you should ask.
Okay. So, can you see this image? You have two different type of cameras within a one camera. Like you have two different cameras within a one, and this has some kind of benefit we have. What kind of benefit we can get if we have one camera and it has two lenses, like two different picture it is capturing at the one
Yes,
time?
ma'am. Uh, yes, ma'am. We can actually get the depth of the object. We can know the distance of the object and background blur. One is the main camera and the other is the depth camera.
Okay, just how much cameras you have in your phone?
We have I have three camera and two of them are uh, main and depth camera and one is ultra wide. So depth camera is used to detect uh, the distance of the object. So how much blur should it apply in the background?
Okay, yes, yes, exactly. So if we have uh, 4 plus 2 is equal to 6, where is it? Tanish?
Ma'am,
मैम
he is
4
talking about the
पीछे
camera.
है और 2 फ्रंट में है।
Okay, okay. So like different cameras have different type of applications, and in this camera, if you see that if you have a two different type of two lens, and this lens, like if we are capturing one object from two different cameras, then it will give you a 3D image very efficiently. Like the quality, whatever the property the object have, it will give you very perfectly. Okay, so this is the benefit of getting these two cameras within a one frame. So this is known as the stereometric. If you want the 3D image of any object, then you must use the stereometric cameras. And in the iPhone and in some kind of phones, smartphones, we are getting such kind of stereometric cameras as well. So here we can see we have a pair of metric cameras. We already talked about metric cameras. So we have a pair of metric cameras, and this metric camera have some distance that is known already. Okay, and both cameras have the same geometric property to facilitate the creation of the stereo pairs. Means basically with this kind of cameras we can get the 3D image very perfectly. Okay, so here we have the application of aerial photography. Here, for example, if we are looking into the vegetation area or the forest area, then you can identify where the encroachment is happening, where some intruders are just removing the plants or just killing the animals. So such kind of information you can get from the aerial photography. Then you can also create like text or the revenue map. Then you can create the land use map, the topography map, hydrology map, and based on different type of wavelength you can create it. It is not possible to create with only one specific kind of wavelength, so you must have different kind of wavelength to play with such kind of photography. Then we also have some products, the DEM. Can anyone guess what is DEM? Digital.
No, ma'am.
What next? Okay, so this is digital elevation model. Means when there is a like some radiation is radiating on the object. So based on that radiation that is emitted, you can get whatever the topography we have. Either here is a mountain, either there is a tree. So we can get such kind of images as well. Okay, we can get the elevation in the surface. So this is the digital elevation model. Then we have the orthophotos, thematic GIS data. You will get used to this term when you will have this kind of courses. And we may also create some other derived products or map. For example, we can estimate using this satellite data how much carbon is being stored in the vegetation or the forest area. So how it is possible? Based on how much vegetation we have, based on the diameter of the stem we have, this can be done using the photography. Based on the diameter, based on the reflected light, we can estimate like how much carbon has been stored into that in that forest. So such kind of information about the net primary productivity, gross primary productivity, we can derive a lots of products from this kind of aerial photography. Okay, this is LiDAR you were talking about. So can you guess what it is? What's the difference between LiDAR and satellite?
Mm. Ma'am, I know about it a little bit.
Mm-hmm.
Ma'am, it is a type of sensor
Mm-hmm.
that can uh, that can that can detect the that can detect the distance uh, and size
Yes,
of an
exactly.
object.
Yes,
So,
exactly. So how it is possible that it can measure the distance?
ma'am, I don't know, but it has laser.
Okay, it is just something like that. If we are giving some radiation to the object, we know the speed of the radiation. Okay, so we know the speed, the first thing. Second thing, when this radiation will strike to the object, it will reflect back to the sensor. So we know the time it took to be taken by the sensor, and this time should be halved because it went there, struck there, and returned back. So this will be the t by 2, means time upon 2, because it traveled double distance. So you have the speed of the radiation, you have the time. So based on this formula, you know the formula. What's the formula like that have the relationship between distance, speed, and time? What's the formula?
Distance is equals to speed into time.
Yes, and if we have the speed, if we have the time, then we can estimate like the distance between distance of this object. Okay, so this is the application of lidar. But here the important thing is that we are using the laser light. I hope that from Melas you bought the laser light as well.
Yes,
Have you
ma'am. Yes,
used the laser light?
yeah,
So what's the application of that laser light is?
ma'am. We can point it uh, uh, like anywhere to very far.
Yes, exactly. Means this is not losing the energy. It is just giving sharply energy to some point. Okay, the first thing. The second is wavelength is very particular for that. You are just sending, let's say, you are sending 545 nanometer light to that. Okay, so here the wavelength is very particular, and because of that specific wavelength, you can estimate the speed and then the distance of that object. Okay, so in lidar you have the laser, first thing. The second, it also have the radar. Radar is radio detecting and ranging. Radar means you are using the radio waves to go on the object, strike and reflect. Okay, so this is the radar. uh, so using the laser and radar, you can make use of the lidar. And this is laser scanning, active mechanism. Why this is active, not passive? I told
Ma'am,
you
because
it's been
Ma'am, because it's radiating light by itself.
yes, it is giving light itself, like it doesn't need the sunlight, right? That's why it is passive remote sensing. Sorry, that's why it is active remote sensing, not passive. Yes, and it has already been developed in 1960s. So see how advanced the developed country was at that time. So why we are using the laser? This has the specific interaction with the wavelength, and we can measure longer distance by it. And because it is active remote sensing, then either it is the daytime, either it is a night time, either is a cloudy condition, we can estimate the distance, and we can create the 3D topographical map with this radar pulse. Okay, so for example, we have the aircraft. In that aircraft, we have the laser scanner, and it is sending some signals. Okay, firstly, it has to identify at what coordinate the object is. For that coordinate, it have a two technology. The one is it have a DGPS, that the differential GPS, and it also have the IMU, that is the inertial measurement unit. It means that we have we have a station already. Okay, and this station also have the GPS. This laser scanning also have some GPS. So whenever there is some error, this error can be reduced because of the GPS. Because there may be some error because aircraft is moving. Okay, but just to reduce the error, we also have GPS on the station as well. And based on the based on the difference of error between this GPS at the station and also on the aircraft, we can minimize our error. Okay, so this is kind of the differential GPS. The second is IMU. I'm not that much, I haven't explored much about this IMU. If you people know that, you can tell me. Okay, so based on this laser scanning, first we estimate the coordinate, where the object is. Okay, after that, after that coordinate, we can get the distance to surface, and this is just by the just by this speed is equal to distance upon time. You can estimate the distance to the space. Then because this aircraft is moving, means a same object can be seen by this laser scanning at the different angle. So based on that, we can get the 3D scan. So so this is the lidar mechanism, how we can get the 3D image or the 3D scan using this lidar. We have different component of it is, the first is laser, the second is like we have the laser, then there should be scanner, so scanner and optics. We must have the photo detector and the receiver electronics, because it will give you the reflected radiation as well. So there must be photo detector and the GPS system, that is the positioning and the navigation system. What's the full form of GPS, if you people know? Kuldeep, what's the full form of GPS?
Ma'am, I guess geographical positioning system.
Geographical,
Positioning
Ge-
system.
geographical or the global?
Oh, yeah. Global.
Global positioning system, right? Okay. Okay, so here we can see that we have some building, we have the vegetation, and if we want to get the topography map, okay, so what's the height of the forest, what's the height of the building? So we have different application of the lidar system. The first is LP mode. We can switch to the LP mode. LP means last pulse. Okay, so what do you mean by last pulse? Means for example, lidar is sending you the pulse or sending you the radiation, uh, firstly at the top of the building, and then it will go to the down to the building. Okay, so if you are getting the last pulse, means you are getting the below pulse, means you will get the information of the surface area. Okay, means what's the height of the surface you will get from the last return mode. Okay, but if you want to know the height of that building, then you want to get the first pulse. So based on this first pulse and the last pulse, you will get the height of the building, because the pulse here it will be the last pulse, and at the top of the at the top of the building it will give you the first pulse. So based on the difference between these two type of pulse, you can get the height of the building. So this is the LP mode and the FP mode, and based on this LP and FP mode, you can estimate. Yes, exactly, pulse means radiation or the signal you are sending. Then based on this LP mode and FP mode, you can get the DAM image, DTM, and the DCHM. DAM means digital elevation model. Already talked about it, that you can get the height of the mountains or the hill from it. Then terrain image, like what's the sea surface, sea level surface area you have. Then you can get the elevation of your ground using DTM. This is the digital terrain model. Then we have the digital canopy height model. This can be also estimated making use of LP and FP mode. So this is all about radar and the remote sensing. I don't think that we have more. Okay, I think this is the last slide for the remote sensing part. Then based on the wavelength, we can differentiate between different object, and we can study different object differently. For example, if you want to study the topography, okay, so your laser must have the wavelength of near infrared radiation. Okay, because the reflectance will be very different for this near infrared radiation. So whenever you are studying the topography using the lidar, then it should be the NIR wavelength. Okay, but whenever you want to study the sea floor, then this NIR will not work, because we have to send the green light into that sea floor, because this green light have a good frequency and the low wavelength. Based on that property, it can penetrate the water and you can see the sea floor. Yes, Kuldeep.
So, ma'am, LiDAR can also detect or map the uh, sea sea topography
Yes,
like sonar.
yes, exactly.
So, ma'am, these are different
Sonar
things.
sonar is just giving you the distance. Okay, but here with the green light and with the lidar, you can also like you can also give the information of seafloor map, whether there is whether there is a trench, whether there is a hill or mountain, or there is a canyon. So such kind of information can be provided by the lidar.
Uh,
Yes,
so,
exactly.
ma'am,
Yes.
LiDAR is we can say LiDAR is uh, uh, latest or better.
Yes, lidar has a many application, and see, lidar and radar, or the sonar, these uh, these um, these have a different properties. So we can say that yes, lidar is advanced because we can use different type of wavelength now, because in radar or the sonar we are having a very specific kind of wavelength we can use, but in the lidar we can use different wavelength for the different application. So this is kind of the advancement we have. Is it clear, Danish?
Yes, ma'am.
Okay. Okay, so I think remote sensing part has been completed, and the second part is disasters. This is where I need your help, because I did know about the remote sensing. That's why I didn't ask you the question as well. I thought that you people know very less about the remote sensing. So here in disaster, I think you are the expert. So I will ask many questions from the disaster. So let's say we have uh, can you tell me the recent disaster we had in Sikkim? Uh,
A cloud burst was happened in Sikkim. I it exactly didn't know the name.
this was not the cloudburst, but uh, flash flood, and this flood was due to the glacier. Means like in Sikkim there are so many ponds or lakes. So there are so many lakes that are based on the melting of the glacier. Okay, and if the melting of glacier is high, then these lakes will be overflowed, and if these lakes are overflowed, then it will result into the flood condition. So same thing happened. Glacier melted, and overflow of lake was there, and based on this overflow, there was a flood in Sikkim. So why this glacier melting happened at
Global
that high
warming.
pace? It may be global warming, or
Yeah, and
what could it?
summer time, ma'am, summer.
Summertime. There are so many different reasons. Like the one is obviously the overall is the climate change or the global warming, but uh, there are many different cases we have based on which glacier has been melted. Okay, so we are not going into that much depth. Okay, so just focus on the disaster. So what happened in Sikkim? This is not the hazard. Whatever the flood it was not the hazard, but it was the disaster. So what are the main characteristics of the disaster? Danish, Kuldeep, what are the
Um,
characteristics of the disaster? Yes.
Ma'am, if we talk about disaster, it is a grave problem that affect the all forms such as the social, economy, or the livelihood of the people. And at that point of time, the people are not able to use their own resources.
Yes, exactly. Means, uh, for example, if there was a flood, okay, but if you had if you had the potential to cope up with that flood, then it you will not call it the disaster, right? Is it? For example, there are most every year there is a cyclone, or there is a cyclone in Odisha. Okay, but somewhere Odisha capacity has been strengthened in such a way that if there is a cyclone, then there will be no devastating effect of that event. So we will not call it the disaster, because people, or let's say the wildlife, or let's say the other thing has been under the control, and these are being not affecting by such kind of events. So these events are not disaster, but disaster is when these are impacting the human life. Yes, the social, economic, every from every perspective it is affecting us. Okay, so this is the disaster. Here we can see that it can be arise due to natural and man-made causes, or by accident or negligence, and it will result into substantial loss of life, or the human suffering, or damage to, or the destruction of property, damage, or the destruction of environment, as you told, social, economic. And then it is at a such a nature or magnitude that we can't cope up with. We are the magnitude is beyond the coping capacity of the community of the affected area. In that condition, we will call it a disaster. Okay, but for example, if there is a one state that if you know that in USA, there is a tornado. Okay, every year tornado comes, but the effect of this tornado, it is not that much high. It is not affecting the people, it is not affecting the property of the environment. Why? Then we will not call the tornado it is a disaster. But in case the tornado comes in India, then it will be a disaster for us. It means whatever the background condition we have, whatever the social condition we have, whatever the capacity we have, based on that we will identify it is a event or the disaster event, right? So okay, so we have two different type of, you people already know, natural and the human made. In natural we have tornado, flood, wildfire, earthquake, drought. And human made we have like industrial accident, oil spill, war. Can you identify which one is common among natural and human made disaster, among the picture I show you?
Ma'am, flood.
Flood, can flood be a man made?
Yes, ma'am. Kind of like if we construct a dam and the
Yes,
dam is like broken, so there will be flood.
yes.
And
Wildfire can also be human made, right?
yes, ma'am. If someone is,
Earthquake,
yeah,
how earthquake?
ma'am, earthquake, ma'am, use of nuclear weapon.
Yes, if
I
you are
don't know,
doing
ma'am.
some kind of detonation to break the mountains, if you are doing some kind
Yes,
of
ma'am.
mining activities,
Yeah, ma'am.
so this can create the earthquake. How drought?
Typhoons,
Yes, how typhoons?
Landslide.
because of climate change,
Okay, how drought?
because of overexploitation of water resources.
And it may be possible that if we are diverting our river or the water stream from that area to some another area, then it will create the drought as well, right?
Yes, ma'am.
And ma'am, landslide.
A landslide, yes. How this can be happened by human
Uh,
made?
ma'am, people are settling in like hotels region, so they are imbalancing the nature. So landslides occurred usually in
Yes.
Himachal Pradesh, Uttarakhand.
Yes, exactly. And because of the activities we do for constructing the road, we are using the bulldozer as well, right? And because of that bulldozer, we are breaking the rocks. We are just losing the cohesion capacity of the rock with each other. So based on weakening the connection between rock, we can this can also lead to the landslide as well, right? Okay. Then these are the man-made disasters that can be train accidents, that can be aviation accidents, shipwreck, traffic collision, structural collision, bridge collapse. So whenever we have some impact after that incident, then we will call it a disaster, because we don't have the capacity to control it. We don't have the capacity to resist the adverse impact we have on the human or on the environment. Then this will be known as the disaster. Okay, so we have some terminologies for the before coming back to the disaster. So the hazard, what's the difference between disaster and hazard? Yes, Danish?
Ma'am, in
Yes.
hazard, I think there is not like damage to infrastructure or economic damage. This is limited to um, human health and human casualty.
Okay, Danish, you are also giving answer.
Yes, ma'am. Ma'am,
Yes.
hazard basically causes like loss to life and environment, but like um, hazard is a part of disaster.
No, actually, the thing is that let's say you are working somewhere wherever there is a higher use of like explosive chemicals. For example, you are creating something that needs the explosive chemicals. Okay, so these chemicals, the if there is some kind of mismaintenance, then these explosive chemicals may lead to the disaster. Okay, but we will say that because we are using the explosive chemicals there, then this may cause a disaster, but these are not causing the disaster. Because it is a hazard only, like it may cause the disaster, it may cause some kind of accident, it may cause the loss of life, but we are just awareing ourselves, warning ourselves. Yes, because there are some work that are related to the explosiveness, then we must take care of it. Okay, so this is kind of hazard we have. For example, in the laboratories, we are using different type of instruments. Okay, and different instruments may have different kind of hazards. Okay, so these are kind of for example, if you have a road that has a very high curves. Okay, so because of that high curves, the chance of accident has been increased. So this is like there will be a board that will give you the hazard warning. Okay, so disaster can be happen, but it may or may not be that this hazard may turn into the disaster. Okay, so this is the hazard. So this is the process or phenomena or the human activities. So that may cause the loss of life, injury, or the other health impact. For example, we are constructing a 50-story building. So there may be hazard that people may fall off from that building while constructing it. Okay, so this is kind of hazard, but this may or may not lead to the disaster. Then we have the hazardous event. When that hazard happen at that particular area, then we will call it a hazardous event, and it may be that this hazard event may turn into the disaster or not, based on the capacity we have to cope up with that hazardous event. For example, I'm working in the laboratory, and that laboratory have a very explosive chemicals, and it happened that because of that explosive and because of the mismaintenance I did, uh, a fire has been broken up. Okay, so fire has been broken up means hazardous event has been happened already. Okay, but it may or may not give the impact to me. Okay, maybe because I have the fire extinguisher, or may I also have some other type of facility through which I can douse the fire. So this may not turn into the disaster. Disaster is when there is some impact on the human or on the environment, but this is only the hazardous event because of some hazard condition we had at that particular time. Okay, so this is the hazardous event. Then we have the exploser, then vulnerability, and the disaster risk. So can you differentiate between these three terminologies: exposure, vulnerability, and disaster risk? You can just guess. I'm not getting. I'm not expecting the right answer from you, but if you are giving, then it's good for.
Okay, ma'am. Exposure is like if we are yeah, if we are living
Mm-hmm.
near a factory
Yes.
that is using the chemicals like you told us,
Mm-hmm.
so it can impact our life. If something happened, then it will impact the society nearby.
Yes,
uh,
exactly. So the society or the your house you are residing into, so this is come under the exposure, right? Because you are exposed to the hazard prone area. You told it right. What's about the vulnerability?
Let me just read it.
This is
Ma'am, actually I'm reading it.
what you are doing, what you are
I'm
saying.
reading it.
Okay, okay, you are reading it. Okay, just read it. I have a lot of time. We can discuss. Are you able to
Ma'am,
answer?
ma'am, not really.
Okay, so for example, if there is a factory and that factory have very explosive chemical, right? And near to the factory you have a house, means you are exposed to the hazard area. Okay, but it may be happen that your house is that much strong, or you have a system like you have the air purifier, or you may have like different technology you have inside your house, or like you have a very much strong concrete house, so that whatever the effect can be happened due to that industry, it will not affect you. Okay, this is the one condition. The second condition is, if you have a house and if you have a house that is not very concrete in nature, you don't have other facilities such as the you don't have ROs, you don't have air purifier, if you don't have, let's say, the financial support as well. Okay, so and when any hazardous event happens, so it will affect which type of condition, the first condition or second condition? uh, the second one, because you don't have the financial support, you don't have the air purifier, you don't have the water purifier, you don't have that much resources to cope up with that condition. It means that if you have such condition, then you are highly vulnerable to the exposure. Okay, but if you have a very good financial condition, if you have a very good house, if you have other facilities, then if hazardous event happen, then you will not be that much affected. So this is like you are less vulnerable to that. For example, I give you example: global warming is happening, and if one house has the AC and one house is not, if heat wave comes in the summertime, then the one that have the AC will cope up with the heat wave, but the person that have not the AC, it may be that he can die because of that heat wave. Means the person that don't have the AC is more vulnerable to the event, but the one that have the AC inside their house, maybe like he is the less vulnerable. So it is a kind of sustainability you have. So is it clear what do you mean by vulnerability, Philip?
Yes, ma'am. Yeah, ma'am.
Okay, then we have the disaster risk. This is the potential loss of, like, in case there is cyclone, in case there will be the flood, so how many people can be die off, like how many house can be broken off, like how many things can be happen. So such kind of things will come under the disaster risk. So if you see here, if we have the vulnerability, hazard, exposure, so it will create a risk. Okay. uh then disaster we already have covered. Uh, so this is the hazardous event that interact with the exposure, vulnerability, and the capacity. And based on that, if we have higher exposure, if we are more prone to that, event, and our capacity is very less, then no doubt it will lead to the disaster. Okay. Okay, then disaster has been occurred already, then you must have some strategy to cope up with that. And we have the disaster management, we have the contingency planning. So what do you mean by disaster management? Can you guess, Danish, Kuldeep?
Yes, ma'am. Mm, a management to mitigate uh, to mitigate the disaster.
Miss, you are planning something, right? You are planning something to cope up with the disaster.
Yes, ma'am. Yeah.
Uh, Yes. For example, because you know that every year cyclone comes. Okay, so you can track the cyclone, like in what area this cyclone will occur at what time. And this type of work has been done by IMD, Indian Meteorological Department. So so that we can get the exact time when this cyclone will occur, at what place it will occur. Based on that, we can plan more. For example, we can give the directory to the people that please don't go outside your house, because this is the time, this is the place where the disaster can be happened, because the cyclone will occur there. Okay, so such kind of things, the planning we do, we have some kind of organizations for that, we do planning, we have some application of the measure. For example, I told you how we can track the cyclone, how we can track the monsoon, and how we can track, like, when the precipitation extreme can be happen. So such kind of things will come under the disaster management. How we can manage the disaster, we have different technology, we have like different organization for that, we have different analyst for that. So based on these kind of things, this is we can manage our disaster, and this is comes under the disaster management. Then we have the contingency planning. So this is also the management process that analyze disaster risk that we can have, and establish arrangement in the advance. For example, if you know that yes, there will be a cyclone or the earthquake in a meantime, then you can create some temporary shelters, and you can the supply of food can be increased and that prone areas. Okay, so this is kind of the contingency planning. Then the early warning system, as I already told, that we can do some kind of forecasting if we are using some data input into the model. So based on that, constant monitoring or the constant forecasting, constant modeling thing, we can get the forecasting whether an event can be happened or not. So we can release the early warning system for that. Capacity, as I already told, that if we have, let's say, for to cope up with the global warming, if you have AC inside your house, alternative to that, if you have a higher number of long trees you have inside your house, that can give you the cooler air. So such kind of things may prevent the disaster effect to your life. Okay, So this is all about the capacity. What's the strength, the attribute, the resources available within an organization, so that you can cope up in case an hazardous event comes or a disaster comes. Okay, so this is the capacity. Build back better. What do you mean by it? Like, this is the terminology you can easily explain. Build back better.
Yes, ma'am. If
Yes.
something is disrupted with a disaster, like
Mhm.
a town, there was an earthquake, the buildings are now destroyed. So now, if the town will revive, so it will make itself even better than what it was.
Yes, exactly. Means if
All
there
the
is a,
things will get done. Yeah, ma'am.
yes, if there was an earthquake, and because of earthquake your building has been destroyed, but because you know that your building should be just like that, earthquake doesn't affect your building. So the material, the structure you will use for your building will be very different from the previous year's one, so that next time if earthquake occurs, then it will not affect your building. So you are coming again with the better options. So this is the build back better. Exactly, you told it the right. Then we have the disaster management cycle. Can you explain, Danish? Danish, are you here?
Yes, ma'am.
Okay, so what do you mean by disaster management cycle?
Ma'am, basically, disaster management is the planning or getting the strategies to overcome any certain disaster in a
Mm-hmm.
particular time. So there is a cycle like uh, in early we get like we do like something like research. No, not research. We have early warnings, and
Mm-hmm.
then we do like research and rescue if the disaster happens. Then we do like emergency relief, then we reconstruct or rehabilitate, and further we take prevention from another like upcoming disasters. So we say we have to first do, we have to be prepared for the disaster, then we have to respond in accordance with the disaster, what happens in the course of time. Then we try steps to overcome or recover the loss done by the disaster. And at the last stage we try to mitigate or to like prevent the following area from further disasters or the loss.
Yes, yes, exactly. So I want to know one answer. Like, you use the terminology mitigation. So what's the difference between prevention and mitigation?
And prevention is basically like preventing or to like big do like we are saving ourselves from something. And
Mm-hmm.
mitigation, as I know it, like reducing the things, like reducing the possibility to be like it get destroyed or it get
Yes,
like
means
ruptured.
reducing the impact.
Yes, ma'am.
Yes, Kuldeep.
Yes, ma'am. Yeah, like mitigation is like if there is something that we cannot stop it, like if there is volcanism in Hawaii Island. So what can we do with the volcano? We cannot do anything, but we can save the people. We cannot stop the lava by constructing a ball, but we can actually mitigate the thing.
Means you can't prevent the event to be happened, but if the event happened, then you can avoid the impact of that event.
Yes, ma'am.
Yes. Okay, so disaster management cycle is, as already Danish told, then if the disaster has been happened, then what will be the action? How will you manage with the impact of the disaster? Then you will respond very quickly. Then after respond, it may be happen that something has been destroyed, it may lead to the injury to your life, injury to your like building. Then you will recover. Then because you know that this kind of disaster happens, then you will try to avoid the condition with the mitigation and the preparedness. Okay, and this is the one way. Then another way is that the search and rescue, of course, and then the emergency relief, rehabilitation, reconstruction, prevention, and early warning. This we have to do to maintain, so that we can be strengthened enough to get very less effect of this kind of disastrous events. Okay, so we have a definition of these terminologies. So the prevention is action to stop an event from occurring. For example, you know that you can stop the food poisoning to maintain the hygienic condition, but for the natural disaster it is not that much possible. You can't prevent the natural disaster. uh, then we have the mitigation, means the action to eliminate or to reduce the loss of the life and the property. And the preparedness, these are the plans or the procedure you designed to save the life or the properties when any type of emergency occurs. So this is the preparedness. Then the response, the whatever the action you will take before, during, or after the emergency, this will be kind of the response to focus on saving the life and the property. Then the immediate help and relief, if emergency has been if there is a need to do something just after the emergency, then some medical assistance, some like providing the shelter or food, you will provide some facilities to that area. So this will be the kind of the immediate help and the relief. Then the reconstruction and rehabilitation, you already know that if the building has been destroyed, then you have to reconstruct it. If the road has been destroyed, then you have to reconstruct it. Rehabilitation is the restoration of basic services. For example, because of flood, because of something, the telephone wires or the wires, electricity wires has been broken up, so you want to restore the original condition, you want to restore to the basic services. So this is kind of the rehabilitation. Then we have Prime Minister 10-point agenda for the disaster risk reduction. If we follow these 10 agenda, then there will be very minute cases when this disaster or this hazardous event will lead to the disaster. Okay, so these are the integrating disaster risk management in development. Whenever you are doing some kind of development, if you are constructing something, if you are constructing a lab, for example, in which you have the explosive chemical, then you must care of like you must have in your mind about the disaster risk management. If this happens, then what should be the what should be the step you should taken for the prevention of this kind of accidents, or if that accident happens, then how we can cope up with that. So in the development, we must have this disaster risk management. Then the risk coverage for all, either it is poor or rich, you must the risk coverage should be for the all people. Then there should be the woman leadership in risk disaster risk management. Why human leader why woman leadership? Why there is a need, why there is a specific thing that human leadership should be there for the disaster management risk? Can anyone guess?
Ma'am,
Ma'am,
Okay, who will speak first? Danish, speak.
okay, ma'am. Ma'am, as I'm understanding, like women leadership is important because in disaster are lots of like loss of everything, like life, property, and everything. And like women can console and like they can like cajole all the things in a very smooth manner while the men's cannot do. They can do like heavy things. That's why I think women leadership is very much important.
Okay. But the important thing is that either it is a man or the woman, these two pillars should involve very equally in the disaster risk management. And if we talk about women's, because previously, because women were not that much educated, they are just inside their houses, so these women do not know about the disaster risk management, and these women are like do know all about the houses, do know all about the nearby things, so they can these women can help better in the disaster risk management. Yes, Guldev. Dev, you want to say something?
Yes, ma'am. Ma'am, I think women are more sensible in these situations. Uh, their nature, they are emotionally intelligent, so they know what to do it at that specific moment. So that will also help to revive people or the society effectively. That's my
Okay, okay. So I'm not going through all these 10 points you people read, because we have a very shortage of time right now. So these are the 10-point agendas. Okay, then the third is valuation of the natural resources. So as in week 10 already we have talked about it. For example, if we have a forest, then interest list come, and this interest list want to just cut down this forest for the mining purpose. So how will you convince the government, the court, that forest is important for us? So there must be the evaluation, or there must be the valuation of the natural resources in the money. For example, if you are saying that yes, mining will give you the 5 crore rupees in 5 years, but forest will give you the 10 crore rupees in the 5 years, then you can win your case. In that case, you can conserve your natural resources. Okay, so and how we can calculate this? How did we calculate that? Yes, there is a 10 crore rupees, then we can get from forest within 5 years. So we must know some kind of method through which we can calculate the quantitative value of that forest or the natural resources. Okay, so it is important for us to know the methods, to know how we can do the valuation of the natural resources to conserve our resources, and for many purposes. Okay, so we already talked about it in week 10, that we have natural resources that are biotic in nature and as well as in abiotic in nature. Then we have the renewable sources and the non-renewable sources. We already have covered it already. Then we already covered this slide that we have also 4 different type of resources based on the stage of development. The first is potential, actual, reserve, and the stock reserves. This is just the recap because we already have covered it. Okay, so we need the economic valuation because of 3 points. The first point is to aid cost benefit analysis. What do you mean by the cost benefit analysis, Kuldeep? Danish? Yes, yes, Kuldeep. Do you know
ma'am.
the cost
No,
benefit
no, I don't
analysis?
know. No, no, ma'am.
Okay, Danish?
Yes, ma'am.
Danish, do you
Yes,
know
ma'am.
about the cost benefit analysis? What do you mean by cost benefit analysis?
Ma'am, I do. I know a very little about it. Ma'am,
Okay.
basically, cost benefit analysis, we can say, is a process where
Mm-hmm.
we can measure the benefits or the decisions that like uh, we
Yes.
can say like
See, cost benefit analysis is just like how much you are investing. It may be that after investment, you may
yes,
be
ma'am.
in profit or you may be in loss. right?
The
So before,
return of investment.
yes, so before investing your money, you should have to do the cost benefit analysis. Like, what is the possibility that you will get the benefit, and how much benefit you can get after 10 years from that. And it may be that you may get loss after 10 years. So you must have some kind of analysis before investing. So for example, if you are investing in the mutual funds, then you have to do some cost benefit analysis, like in which companies you are investing your money, and what can be the future of that company. If that like if you see the trend of the growth of the or the turnover of that company, you can like do some kind of analysis, like you will get benefit or not, you will get loss or not. So such kind of analysis you do before the investment. Likewise, if you have a natural resources, then if you are diverting this natural resources to, let's say, you are creating a hospital, okay, so you have to do the cost benefit analysis for that. Are you getting the same benefit, or are you getting more benefit to create the hospital as comparison to the forest you have in that place? So such kind of cost benefit analysis you have to do. And this can be possible only if you have the methods for the evaluation, or if you have the, like, if you can measure the benefit in the money way. Okay, so to aid cost benefit analysis when the natural resources is being diverted, okay, you must know that how much cost, how much investment we already have done, how much benefit we will get from the forest, and in case we are diverting it for the cropland or for the agriculture, how much cost we have to how much expenditure we have to do on that agriculture land, and what kind of benefit we can get. And we will see the input and the output. Based on that, we can decide whether the forest should be diverted or not. So this is the cost benefit analysis. Then second is to provide evidence to aid habitat conservation policies by highlighting the economic value associated with the conservation. No doubt, because of the conservation, uh, because of the protected area, because of the national park, a lot of wildlife has been conserved. Okay, but a lot of benefits we get. So if we want to win the case against the industrialists, then we must have the economic valuation. Then to evaluate economic compensation legally required for damage to natural resources through polluter pays principle. For example, if there is a condition that yes, you have to divert your let's say forest to the company, then what compensation should this forest get by diverting it? Okay, so this can be done only when you know the value of that forest in the quantitative way. So these are the need for the economic valuation. So we have two type of method. The one is use value and the second is non-use value. So when you are using the resources of the forest, that will come under the, like, you are just finishing, or you are using it. Okay, that will lead to the reduce of the product you have in the forest. Then it is the use value. If you are if you are not just finishing it, or if you are not depleting the resources, but you are getting benefit from that forest, then this will be the non-use forest. For the use forest, we have the direct use, indirect use, and the optional use. And non-use value, we have the bequest and the existence value. So we will cover it very fast. Use value means value arising out of the use of the resources. In the direct use, for example, if we are using the timber, if we are using the firewood or the medicine, then we will get some money out of this selling the timber or the firewood. Then this will be the direct value. Non-consumptive values as well. If you are using this kind of forest for the educational or the research purposes or the habitat purposes, then this is also the direct use. Then the indirect use, for example, these forests are recharging your groundwater. If these forests are storing the carbon and just acting like a sink of carbon, such kind of uses come under the indirect values. Then the optional is like you are just keeping is the alternative. If something happen, then you can use it. So this kind of value will come under the optional value. Then if we talk about the non-use, then we have the existence, altruistic, and the bequest. So you can read it and tell me like what's the difference between these three: existence, altruistic, and bequest. Existence value means, can Danish you guess?
Ma'am, existence value is the value we are deriving from the resources which are continuing or existed.
Okay, so it means that, for example, you know that you have like one house to reside into, and you also have two properties. Okay, and you know that these two property can help you in the future. So you are satisfied that you can use it in the future. Okay, so this is kind of the existence. You know that you have two property that exist. Okay, and that can give you benefit in the future. So this kind of value will come under the existence value. Means you know that there are the resources that you can use, but and you know that these kind of resources exist. Okay, so this will come under the existence value. Altruistic value means you know that these resources you are not using it right now, but you can use uh, you can sorry, altruistic means like for the benefit of the others. For example, in the Sikkim, you know that there is a forest and tribal people are using it, but you are in the Haryana where there is a no forest, but you are happy that someone is using that resources. Tribal people in the Sikkim are using that kind of resources, so you are happy with that. You have the satisfaction, you have some value for that forest. Okay, so this is kind of the altruistic value. Then we have the bequest value. Bequest value means we are leaving something for our next generation. So this is kind of the bequest value. Then we have some method of the valuation. The first is market price. For example, if you are selling the timber out of this forest, so how much value you will get after selling this timber. So this is kind of the market value. What you want to, what you are willing to pay. Then this is the one is market price method. The second is hedonic price method. What do you mean by hedonic? Have you heard before? Hedonic price method, Danish Kuldeep?
No,
Ma'am,
no, ma'am.
could you please repeat, ma'am? I'm not get your voice properly.
Okay, so I'm talking about different type of methods by which we can evaluate our natural resources. First, we talked about the market price. How, like for example, if we are selling the timber, so how much amount we will get from the timber? This is the market price. So the second is the hedonic price method. So what do you mean by hedonic? Have you heard it before?
No, ma'am.
Okay, for example, there is a 10-story building, and you for and this is a building. At one side there is the forest area, or let's say the ocean you have. In the another side you have, let's say, the dump yard, where so much garbage is here. Okay, so which side you want to you want to take the flat, in the dump yard side, or for the ocean side, or for the or in the forest side? Which side you will try to purchase the house? Kuldeep, Danish?
Yes, ma'am.
which side you will purchase your house. If there is a one side, there is a forest area, and in the second area there is a dump yard. So which side you will
Forest area.
yes. And if there is a, for example, if you are if the price of that house is doubled as comparison to that house towards the dump yard, okay, even then, like if there is some increment in the rent, then you will pay it, because there is a forest, or in the another side there is a dump yard. So whenever you are purchasing some properties, then you want that it should be nearer to the forest area or the ocean area or the facilities. Okay, so it means that the increment in the price of that building is due to the forest area. So this is kind of the hedonic price method. Okay, then the travel cost method, whenever there is a like something to see inside the forest, then you have to travel, and whatever the cost of the travel, whatever the cost of the tourism, you have to pay. So this is the travel cost method. Then then the circumstantial evidence, in which replacement and the damage cost avoided method means, if you are replacing, then how much compensation you have to give. This is the replacement. Damage cost avoided means, if because of that deforestation it may be happened, then the atmosphere may be contaminated with different type of dangerous gases. So how can you avoid that kind of damage? So how much money you have to pay? So this is the damage cost avoided. Then we have the contingent valuation method inside within this survey, means you are asking the people, like, okay, if you are diverting, how much amount should we pay to you? So this kind of method will come under the surveyed or the contingency evaluation method. So this was all about this. Can we solve this assignment within 1 minute, Danish?
Yes,
Okay,
ma'am.
ma'am.
Yes, ma'am.
Okay, ma'am.
Okay, so the first question is, which of these is not a use value? Mm, Kuldeep,
Option
Dami?
value.
Ma'am, option value.
No, we have existence value. I showed you the picture there.
Okay.
Here, see, in the use value, I have the direct option and indirect, but non-use value I have the bequest,
Okay, ma'am.
existence, and altruistic as well. Okay. The second is, there is some kind of definition, and you have to tell me, like, this is of what terminology the question is
Ma'am,
talking about. Yes.
ma'am, it is hazard.
It
Ma'am,
is hazard.
vulnerability.
Yes, it is vulnerability. What's the difference? What do you mean by vulnerability, Kuldeep?
Yes, ma'am. Vulnerability means how much we can absorb, uh, how much we can uh, we can actually wear.
Like,
Um,
no doubt, if you have two house, both house are near to the company or near to the industry, like, but one house may be strong enough to cope up with that effect, but one house is not. Okay, so this is all about the vulnerability. Okay, the next, process, phenomena, or human activity that may cause loss of life, injury, or other health impact. So the definition is for
hazard.
hazard. Okay, yes, because it may cause, it is not causing, right? Which of these uses imputed willingness to pay? I think I covered it very fast, so it may be difficult for you. Let me show you. What was it? Okay, this was inside this.
Yes,
Yes. So here we talked about the market price or revealed willing to pay. Here we
travel.
this is the intention we are showing to willing to pay. So
Damage cost.
yes. Uh, yes.
No.
Contingent
Yeah.
valuation method.
Imputed, you will get like replacement cost
Sorry,
method.
replacement.
Okay, the next one.
Disaster.
Yes, exactly, because there is a serious disruption. Next.
Disaster.
Yes, Danish.
Bequest value.
Not a non-use value.
Non-use value.
Yes.
Weaker.
No, 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 no. Bequest, existence, and altruistic comes under non-use value, but direct value come under use value.
Ma'am, so there should be, if this, there should be not, there should not be the this thing not.
What? I'm not
It should be
understanding.
like, ma'am, it should be like which if these is a non-use value. मैम देयर इज नॉट ये नॉट नहीं होना चाहिए था ना मैम सॉरी
So that's why it's the direct value, no? Because there is a no.
मैम नॉट भी आ रहा है देन नॉन भी आ रहा है
See, non-use value. I show you. Which is not non-use value. Direct is not non-use value.
Ma'am, it's a very tricky question.
No, if there is two no, then it should be cancelled out. This is very this is a trick. For example, if there is a note
Yes, ma'am.
and no, then you should cancel it out. It means which if these are use value. So the question will be like that. So this is the direct
मैम
value.
एग्जाम में ऐसे ही होता है ना, लाइक हो
Yes.
जाता है और
So cancel out two no with the empty. Okay. Then okay. For the bathymetric, which type of light we will use in the lidar?
green light.
Green. Yes. Okay. Next question. It is also the definition. The combination of all strength, attribute, and resource available to reduce disaster risk.
Disaster management.
No, it's the capacity. You are increasing your
Okay.
capacity. You are gaining the strength. You are just storing the resources, whatever available you have to cope up with the disaster. So it's all about the capacity, right? Okay. The next is the value of living use and non-use values for offspring or the future generation is called. It's called bequest.
Bequest.
Okay. The frequency of flyover is an indicator of which type of resolution?
Spectral or ma'am,
How much time a flyover or the aircraft will move? For example, if a flyover is flying over a surface 10 times a day. Okay, so means you are getting 22 by 10 hours data. Is it?
temporal.
Like how frequently you are getting the data, how frequently you are getting the data, so what type of resolution it will be? For example,
Tem-
you are getting data weekly, you are getting data monthly, so what type of resolution we are talking about?
uh, spectral.
This is temporal. Temporal means
Temporal.
time. Temporal means time. For example, if you are getting data daily for one object, or it may be possible that you are getting data monthly for that object. So it's about the time when you are getting the data. If you have more data, then you will get the reliable result as well. So flyover will give you the temporal resolution. Okay, the frequency of flyover. So this was all about the assignment solved. And yes, thank you. Thank you so much for this. I think we have been late. Okay, any query? Any query?
So, ma'am,
No,
this